So now, yeah. So now we're geothermal. So Mike Tippy. Yeah, the program's called REPScreen. It's a free program that the government supplies, and there is REPScreen training because you won't be able to use it from first draft. It takes a while. Intercan. Yeah. There is training from time to time. We get bulletins that training's gone through, and the training is typically free, I believe, too. So yeah, very powerful program. It's a modeling tool for more than just solar hot water, for any energy efficiency also.
Hello everyone, my name is Michael Tiffey. I have my company is Tab Mechanical. I do sustainable building consulting and products supply. I'm a lead AP, lead accredited professional, and I serve hopefully your needs on the Canadian Green Building Council on both the education committee and lead for existing buildings, and I also serve as a course reviewer and education provider for the U.S. Green Building Council. I'm going to cover off on geothermal this evening quickly for you, because as Rick stated, we're going to talk more in depth on Thursday for the people that are interested in these technologies. It'll be more in depth, we'll have more information. So this is just a brief overview. Where have we been here? The down arrow. I'm trying to push the mouse. Okay, that's what I thought. So basically a heat pump is a refrigeration device. I've worked for them with them for years, being an HVAC journeyman and a gas fitter. You're basically, same as your refrigerator at home, we're moving heat from one area to another area. So in this case, we can, in the picture I've shown, we're showing an air source heat pump where we're taking air from the, or heat from the air and putting it into your house, or vice versa in the summer, where we're removing heat from your house and cooling your house down and dumping that waste heat outside. Okay? It's a vapor compression cycle that's moving that heat. So we're getting our efficiency by increasing the compression of the gas, and we are able to take your energy input and get a bigger energy output out the end. Okay? Depending on whether we're talking about an air source heat pump or a ground source heat pump, we're looking at 200, 300, 400% efficiencies. Okay? We're able to take that 1 kilowatt of power you put in, and on a ground source system, get upwards of 4 kilowatts of heat back. Come in a wide variety of configurations. Okay? You go from airside ones, from ductless splits, which do single zones, to full house systems, air source, ground source. We have different various loops that we're going to discuss. And you can do both space heating and cooling, as well as domestic hot water heating with your refrigeration device. In the residential market, generally we just do that space heating, space cooling. Okay, it's more so when we go into a commercial where we see dedicated domestic hot water heat pumps. Those are coming down the road. The first Energy Star ground source domestic hot water heat pumps will be released this year in the States. That's on the horizon. We're going to see that. And so we'll see more domestic hot water. In Asia, we're actually gone to now using carbon dioxide as a refrigerant, and we have air source domestic hot water heat pumps producing hot water for industries, for commercial applications such as hotel domestic hot water needs. And now we're actually, with carbon dioxide as a refrigerant, we're actually upwards of 500% efficiency on them. That's down the road though. Carbon dioxide as a refrigerant in our North American environment is still really in the pilot phases. When you watch a TV program though, you're going to hear geothermal, And geothermal and geoexchange are two terms. If you're watching a television program, a news program or such, and they're mentioning geothermal, they might very well be mentioning an actual geothermal system where we're tapping into a geothermal supply in the core of the earth, very deep. And so that we have in Iceland, as an example, right? We have a lot of hot springs and such. They are producing electricity using geothermal. When we're talking heat pumps, we're actually talking about geoexchange. The governing body in Canada is actually referred to as the Canadian Geoexchange Coalition. Geothermal is a term that gets thrown in there. So when you are watching an American program, a lot of times they might be actually talking about geothermal in this regard, because they will be talking about places in Utah, Nevada, where they have hot springs, and they're utilizing that hot water directly from the earth without the use of a refrigeration device. Here's a picture of a installation, a loop installation, a horizontal loop installation. When we talk about ground source heat pump systems, we're going to talk about closed loops generally, but we can also have a geoexchange system, which is an open loop system. An open loop system generally uses surface water. So whether you have a lake, a sufficient size pond, it needs to be a sufficient size to be able to use a pond, or a lake, you need to have sufficient water flow if you want to draw from a well, an open well, or from an open creek, okay? You, of course, have potential for contamination when you're dealing with open systems like that. Closed loop gives us greater flexibility in usage, and typical systems are closed loop, the systems we see. With a closed loop, we're going to have a bit higher pump requirement in terms of pumping that fluid around in that closed loop. Antifreeze is typically used, glycol, another name. And we have more stable loop temperatures with some designs. Ground surface water obviously changes with our ambient outdoor air temperature. If we go to a ground source loop, then once we get down below that frost line, we're into a stable earth temperature. So we can predict the performance of the device a lot better. Open loop advantages, of course, though, is that we're going to have a lower installation cost than that closed loop. We're going to have lower pumping cost, as I mentioned. Disadvantages, typically on an open loop, it's a smaller system, because as we get a bigger system, bigger home, bigger building,